Hey guys, what's up? Hopefully you've had a good day so far. I know things may be a little crazy for you, but we're looking at solving some differential equations here. And the first the differential equation I want to solve here is a linear differential equation. We want to use the integrating factor to solve it, and it's actually very tedious. So this one's going to be a tough one. It's a good one to practice with. If you want to, go ahead and pause, try to see if you can make some progress on it. This would be a good test question in my opinion. It's a very lengthy problem. I would just really try this one out before I finish working it. But the integrating factor here, so the integrating factor, we already have it in standard form. If we don't have it in standard form, we have to divide by a coefficient of y prime, but there's the only coefficient of y prime here is 1. So here's our p of x. Integrating factor is going to be the e to the negative integral, negative because there's a negative sign here, x over 1 plus x dx. And there are a couple of ways to do this integral. Some people would just add and subtract a 1. I'm not going to do that. I'm going to do a U-substitution for this. So I'm going to do a U sub, U equals 1 plus x. And then we could say x would be U minus 1. And du would be just dx. So this would be e to the integral, e to the negative integral of, now that's u minus 1 over u du. So that equals e to the integral, negative integral. Now that's 1 minus 1 over u du, which is e to the negative u plus natural log absolute value of u. So this is all just for the integrating factor. So it's a little tedious, but this is really e to the negative. And then u is x plus 1, so put x plus 1 here, plus natural log x plus 1. Now this is going to be e to the natural log is really just the input, so that's going to be x plus 1 times e to the negative x plus 1. So that itself is our integrating factor. So we have to multiply the entire differential equation by this integrating factor. So we know the left-hand side is always going to turn into the product rule d by dx of the integrating factor x plus 1 times e to the negative x plus 1 by design of the integrating factor times the dependent variable. And so then multiply the right-hand side with x times x plus 1 e to the negative x plus 1. Quite tedious, this integrating factor. So now I've got to integrate both sides. Oh my, integrate both sides with respect to x. So integrate over here. Oh my, let me just make some more room here. So we're basically at step 4. We're not going to forget our plus c, and then we're going to solve for y. I'm going to erase that so I can have some room for my integration by parts, because this is getting a little nasty here. It's really x squared plus x times e to the negative x plus 1 dx. So that's what we're trying to integrate. We're going to do that by parts. So I'm going to create a u column and a dv column. I'm going to do a little tabular integration here to do this integration by parts quickly. Be x squared plus x right here. And my dv is going to be e to the negative x plus 1. Differentiate this u column. So differentiate the u column, get 2x plus 1. Integrate the dv column, that'd be a quick little u sub, so basically e to the negative u du would be negative e to the negative u, so negative e to the negative x plus 1. Differentiate this column, get 2. Integrate this column, we just get another negative, so it's going to be negative negative, which is positive e to the negative x plus 1. And then differentiate one more time, get 0. Integrate one more time, we get negative e to the negative x plus 1. So quite a few terms here. I have to do integration by parts twice. So multiply these two and keep the sign the same. Multiply these two and negate the sign. And then multiply these two and keep the sign the same. My goodness, this is going to be, over here, it's x plus 1 times e to the negative x plus 1 times y equals, well, all of these terms have a e to the negative x plus 1, so I'm going to factor that out here. E to the negative x plus 1 times, multiply these, I would get negative x squared plus x minus 2x plus 1 minus 2 plus c. So this is very involved. What we're going to do is go ahead and cancel may be the wrong word. I'm going to multiply both sides by this term, which means I'm going to get an e to the positive x plus 1 here. And then I'm going to divide both sides by this x plus 1 right here. And I'll also do some algebra. So I'll also do a little algebra here. So to reduce all of this, we should get that y will be negative x squared minus 3x minus 3 over x plus 1 plus c e to the x plus 1 over x plus 1. And just recall, e to the x plus 1 is really e to the x times e to the 1. And if I have a constant times that, I can basically absorb the c, or the e, into the constant. So really I could just rewrite this as negative x squared minus 3x minus 3 over x plus 1 plus c e to the x over x plus 1. And that would be an acceptable solution. I guess the previous one is also acceptable. But either one, definitely good to go. That's definitely a trickier problem. You have to think about it a lot more. You have to really know, you have to be really careful. You have to really know how to integrate. It's a lot going on. So just take a look at that one again. Definitely soak that in.